Hello. 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 So I'm streaming and I have one viewer, so hello to whoever you are. Today I'm going to be talking about clocks and time, and this is an assignment for my 301A creative coding class. So I'm going to be explaining to students how to do it. So if you're watching and you're a student, then this is hopefully helpful. If you're watching this after the fact, of course, that's helpful hopefully as well. But if you're watching live, the advantage is you can ask me a question if you have any as I'm presenting this, and I can answer it here. Of course, if you have a question later, you can ask me a question in other ways as well. And that's fine, just a little slower. So today I'm going to be introducing the final big assignment for this class, and there is one final, which is the portfolio, but this is really the final bit of work and the final push as we face the end of this term. This is week 5 of a 5-week term. So this is it, and we're going to work our way through it. Let me see. It looks like my audio is a little high. Let me see if I can just make sure I'm on the right input and maybe trim it down just a little bit. Okay, so let me get started. Time is an interesting thing, and time is something that I find myself thinking about a lot lately with the quarantine and thinking about the future. And then, what phase are we in? And the sense of time, I think, for a lot of people has really eroded and shifted and changed. I found this article from Mashable about this, like this idea that, and I think there's other articles, it's just the one that I found Googling this morning. But I've seen other articles talking about this, like the idea that time and people's sense of time and how they spend their time is very different in the quarantine. And for me, one thing that's missing is the normal rhythms of, I have kids, and so a lot of the rhythms of a week, especially in the fall, it's much worse in the fall than the spring for whatever reason, but every day of the week has something going on in the evening. It's either Cub Scouts or Girl Scouts or field hockey or soccer or baseball, and literally every day of the week. And then it's church on Sunday, so there's always these daily things to kind of say, okay, what day is it? What do we need to do today? Who do we need to get where by when? So we're always thinking about time and making sure that we're kind of following that. All of that's gone away, most of it now. Now that we're in this different way of thinking about time. For example, we've just started going back to karate, and we keep forgetting because our sense of time is totally different, and so we keep forgetting what day it is, and oh yeah, that's at 4, we need to get there. So this is a way that we're thinking about time. Time is always fascinating anyway. It's just that this particular time, this particular moment, time feels weirder than usual, and that's why I think it's an interesting thing to think about. Now, for this assignment, the idea is to think about it, and of course, time is the subject of many artists and poets as they reflect on existence and duration and identity. So these are all kinds of things that might show up in your work if you're working on a clock. I've just posed a few provocative questions, or questions I think are provocative, about how time might pass. There's this famous Blake quote. William Blake has a quote for just about everything, it seems. And this one is posing a pretty famous question: to see a world in a grain of sand, and heaven in a wildflower, hold infinity in the palm of your hand, and eternity in an hour. And this is one of, Blake always has these layers, and sometimes your first impression of a poem can be very different than the end. And I would encourage you to keep reading this poem and see if you can detect that shift for Blake. Sometimes things that seem nice and kind of pastoral and innocent at first turn out to have these really dark twists and turns in them. And that's I think why Blake it continues to be popular is because of these surprises that you find in his work sometimes. So I recommend this. But thinking about this basic idea, eternity in an hour. What are the ways in which an hour could take an eternity? And there are certainly hours in my life that I can think of that seem just to take a much longer time, moments like the birth of my children, multiple hours in those cases that seem to take much longer than the hour that I will spend broadcasting Twitch today. So these are different ways that time passes. These Twitch things always seem to go by really fast to me. It probably does not seem that way to you if you're watching, but for me they always seem to go by really fast. Or like a class period. But you think about time, I mean, there's one really basic question that I think we're still struggling with philosophically about time, and that is it discrete or is it continuous? So in other words, we tend to think of time as being broken down into units. So hour, minute, second, millisecond, and you can go on down however many decimal places you want to go. But at some point, when does one decimal become the next decimal? Like, how small can we make a unit of time? And there's ways that we could put that into a question of measurement, like what is the minimum amount of time we can measure? But then that sort of that's a shifting of the question, I think, because that is assuming then, or that's putting time in terms of human constructions or human perceptions of that, which I think begs the question that we asked in the beginning. And so it sort of goes back to this idea of is time real, or is time simply the way that humans have to perceive things? In other words, if time is not real, we might not be able to perceive things other ways. Time might be a convenience that human brains are wired to perceive things via, but if so, it would be impossible to conceive things otherwise. So you get very philosophical, in other words, whenever you deal with time. You also get very practical when you deal with time in terms of code, and so that's why I think this is a great project to end this class with. So we can get very philosophical if you want, but you can also get just really nuts and bolts specific about how to build a clock using P5.js, and that's what we're going to do here. Yeah, I mean, there's all kinds of things you can do with time. I mean, one of my favorite ways of thinking about time and space is the Zeno's paradoxes, or the paradoxes of the ancient Greek philosopher Zeno of Elea, who breaks down this idea that that time and space might be discrete or might not be. If they're continuous, if they can be infinitesimally divided, then how can they actually work? You kind of need a whiteboard to illustrate this, and I have a kind of a bad whiteboard, but it's not really going to work. So it's not as good as like literally drawing things on a screen. But this is this is a way to think about time that I think is pretty interesting. All right, so I actually was referring to things that I thought I was showing you, but I was not, and let me just show it to you here. This is the assignment for the clock, and this is got some links in it, several links here. First of all, a link to the William Blake poem, which I commended to you, and then a link to just an article about how time seems to pass weirdly, but you're living in this time, so you know that time seems to pass weirdly. I imagine it does. Unless you're going to work every day or something like that, you don't have those rhythms that you're used to. And even then, work schedules are probably different than they used to be. Okay, but this is an article here about just like an overview of different ways of thinking about time and recording time, and then representing the recording of that time, how those have changed throughout history. So this is just a magazine article, cabinetmagazine.org, and it's gone through different things, and really trying to show what we take for granted about time and how we got here. Like, these things aren't necessary, these things aren't built into the way the universe proceeds. These are things that different people have developed over time and then modified and then used, and then other people used it, and then eventually, as more people use something, it becomes common sense. But that comes from somewhere, and I think that's the main thing that I think this helps us understand. And then that somewhere has these mechanistic containers. Like, the way that to do this has the way to think about time is also expressed in a device for recording that time and conveying that time. And so we can think about it in that sense as well. So read this article, take a look at it, and maybe you'll find some inspiration here. I think one interesting approach to this assignment might be to recreate some other time, one of these ancient time systems, in a different way. Like, to think about it and represent time according to how like a gnomon would have worked, right? So that's something that would be pretty interesting and challenging to do in P5.js, but that might be fun. Now, I want to say that this is an assignment that I've taken most of the ideas from Golan Levin's assignment from his class on creative coding at, where is he, Carnegie Mellon? And so, like, he's put all this online for free, and I mean, open access, so I assume, I'm taking for granted that it's okay to do this. But essentially, I think it's a great idea for an assignment, and so I think it's a good way to look at it. It's a good way to end the semester. And so he's got a lot of material that he's prepared in his lecture notes, and I just linked to his because I think they're quite successful. One of the things that he's drawing inspiration from is John Maida's 12 o'clocks from 1996, as he says here. And this was a series of Mac apps, I guess, or programs that would represent time in different ways, 12 different ways. And they have different ways of doing time. Some are kind of common sense, like digital representations. Others kind of change what you think of in terms of what you need to know about what time it is, but all essentially tell the time, and I think that's really fascinating. Also, conveniently, Daniel Schiffman has taken up this particular assignment and done a YouTube video about it. I do, as usual, recommend and commend you to take a look at Daniel Schiffman's tutorials. They're better than mine, so definitely take a look. One of the things that this particular tutorial ends up with is a working clock, and so if you are trying to complete this assignment, you might want to just start here, work your way through the tutorial that Daniel Schiffman takes you through here, and you'll end up with a working clock. But then, you're not done. I mean, I don't want you to just complete the tutorial. I want you to do something interesting and unique that's your own. And what I want to do today and next really is show you the nuts and bolts or the building blocks that Daniel Schiffman is using here, and then that might let you build a different kind of clock around that mechanism. So he builds one here that looks really nice. It's this kind of, I guess this is like one of the clock options on an Apple Watch. I don't have an Apple Watch, so I don't know, but it looks really good. And so you might think, this is nice, I want to do something like that. And maybe you do, and maybe you can start with that, but I want to make sure you do something else, right? I mean, I want to make sure that I don't look at your clock and just see Daniel Schiffman's. I want to see your clock. Let me show you how to do some of these things in here, and yeah, hopefully it's helpful as far as getting you started. So a main thing to remember within P5.js is that, I mean, it's all numbers, right? Just about everything you're doing in P5.js is numbers. And there's a really powerful function that we can use in P5.js called map. And map lets us translate one scale of numbers into a different scale of numbers. It's kind of hard to understand like that, so I think I can illustrate it, and I'll try to do that in a moment. But first, let's do a couple of basic setup things. Let's make a black background, and let's make this clock a little bigger. Let's make it 600 by 600. And we've been doing P5.js a little bit already, so remember function setup is going to be the thing that runs once, and then function draw is going to run over and over again. So we want to do things, keep track of which thing we're doing where. We will probably be adding a few more functions and things outside of these two, but for now, this is a good place to start. In fact, actually, let me get started here. Let me run this here and show you a couple ways you could even just get started very, very briefly, right? So conveniently, there are some built-in functions that we can access in P5.js that just tell us what time it is. So we can just set these two variables. So let's say I'm going to make a variable here called HR, just to kind of separate it from the name of the function that I'm going to use, which is the word hour. And this naming, by the way, this is the same naming that Schiffman uses in his thing, and that's hopefully going to help you keep it straight. But what I'm going to do here is print the hour and let us see what it is, and that should show up in the console down here when I hit play. So I hit play and it is 11, right? So it's 11, that's right, that is correct, it is 11. Okay. So it's printing it over and over and over again, as you can see, because this is running inside the draw loop. Of course, I do want these clocks to run, and so I need to draw within the hour, I need to print the hour or know the hour every time it draws, but it doesn't need to print it over and over again like this, obviously. This is just for debugging. So let's take a look at a couple other things we can do. We can also know what minute it is. Let mn, let's say, equal minute. Again, this is a function, so I type the name of the function, put parentheses after it, and that just tells the program, hey, this is a function, go get whatever the minute is and return that. And as you return it, assign that number that it is now to this variable mn. And we should be able to see that, but let's make sure we print it here. Let hour mn, so it now is going to print the hour and the minute together. So it should say 11, oh yeah, it's 11:15. Okay, so we knew that, or I knew that by looking at the clock on my computer, but now P5.js can tell me that it knows it as well. Good. Let's do the other thing, second. Notice this is second, not seconds, because we want to know what is the current second. I mean, you could also ask it, like, how many seconds has it been since the last time it was set? Oh, there's a centipede in here. Yeah, I'll deal with that later. Okay, so it's one of those like house centipedes with like the legs that are like up high like that. Yeah, not great, but It's not going to bother me, I think. So, okay, so let's hit seconds, hour, minute, seconds. You can see now it goes through here. Now you should notice, like, it knows the second, but this 23 over here, 2, 14, 23, that means that in the console, that means that this particular message was printed actually 23 times. It just showed me that on one row here just to save memory, but it knows that 23 times. This is running at about 30 frames a second, I think. I don't need to know it that often, really, but for this example, this is going to help me, figure this out. Now we're going to be doing some other things. We might also want to have a more precise way of knowing what second it is. If we're going to be doing any kind of smooth motion based on seconds, then we're going to find it useful to actually make our own seconds function using milliseconds, but that's something that we'll save until we need it, because it takes a bit more structure to do that. As it is, the second value just ticks forward every second, and that's all we need to know for most of the things we're going to do. Okay, so let's, as we can see here, these are numbers, and these are numbers, it's 11 right now, but I know from having done this before that if you go past 12, it uses the 24-hour clock, so the hour is on a scale between 0 and 23. Minutes and seconds are on a scale from 0 to 59, and that's how time works. We're used to those kinds of numbers. But think about all the other things that we can represent with numbers in P5.js. Things like the width of the canvas or of a rectangle, things like the color of different things that we draw in there. Like, for example, if I wanted to draw a rectangle, let's say, you remember the word is rect. Let me go and make the fill some color here. I'll say yellow. And I'll make a rectangle. And if you recall the rectangle function, the way I'm going to use it here is going to take 4 arguments or 4 numbers that it needs to know. It needs to know where is the top left corner, and we'll say 0 and 0, 50. So the top left corner of this particular rectangle is going to start 0 pixels in the x direction and then 50 pixels in the y direction. So it should be kind of here-ish. And we'll say for now, let's say that it's 100 pixels wide and 50 pixels tall. So let's see if that works the way we expect it to. Okay, it does. Good. Yeah, it looks kind of nice. Now I don't want to do any more printing. I will leave that statement there in case I need to double check something or debug it, but I'm going to comment it out for now. Run that again. So now we can see that this is this is a yellow bar, right? So this is not time yet, but this is something we might be able to use for time if we think of this as a progress bar. So a time that is moving from left to right as a value increases, like what hour it is, for example. So let's say it's 11 right now. 11 is about, but not quite halfway through. So we could say for the width, so for this width of the rectangle thing, we could do a couple of things. Like we could say, we could take the width, and if we just use width as the lowercase word width, that automatically references the width of the canvas. So in that case, that's going to be the full thing. That's not really what we want. We want actually something like, well, it's not, we could do width divided by 2 to get us to halfway, but it's a little less than halfway, right? It's 11 out of 23, so it's not quite halfway there. So it's like width minus 2, width divided by 2 minus 1 or something like that. Or we could do something like maybe we could do 11 divided by 23, right? Because that would give us however many hours it is, and then multiply that times the width. Would that give us the right answer? It might. Let's see. Yeah, that seems actually pretty close. And that gets us there. So that might be one way to get that time there. Now this is going to increase as time goes on, but of course we can't do that without accelerating time, so we can't see that that's going to work, but that intuitively seems okay. We'd have to do a different calculation here for the minute and the second. Now I say we would have to do that because actually P5.js has a nice built-in way to handle things like this, because things like this are pretty common in doing any kind of graphics, and so it's really convenient to have what's called a map function in P5.js. So I'm going to use a map function here instead. And to illustrate what a map function is doing, I'm going to go over to, I do have this little whiteboard thing here. And this would be a lot faster to draw if I had like a drawing tablet or like an actual whiteboard with a marker. But we're just going to have to do this, the way it is. So think of those two numbers that we were just trying to interpolate between here. We're trying to interpolate whatever the current hour is as far as within progress within the day, but represent that on a scale that was whatever the width of the canvas was. So let's think of those two values. There it is. Let's think of those two values. First of all, we know that we'll call this one the hours. Let's see if I can draw. Drawing with a mouse is not super easy. Good enough. Okay, so we'll call this the hours. And this little whiteboard thing I'm using does not have the ability to type. So I just have to draw it. That's so hard. Okay, so this is the hours. Sorry, that looks terrible. And then let's think of what we know about this number. Like we know that it can be as low as 0. If I can draw a 0. And as high as 23. There we go. That's rough, but you get the idea, I hope. So let's think of the other thing we know about. We know the width of the canvas. And we know that the width of the canvas can be, well, let me draw my scale first. Let me concentrate. Good enough, I hope. The width of the canvas we know starts at 0, and currently I've got it set to 600, but we can make this anything. And that's part of the beauty of this function is that this function will continue to work no matter what the scale is, as long as we update it to tell it what to do. So, oh yeah, let me keep my coloring consistent. Let me do these in black with the black marker. 0, and we know it's 600, but it could easily be something else, and we don't actually need to know this ahead of time. Right. So this is the one thing I'm trying to do or thinking about is actually setting up a whiteboard with like another webcam pointing at it. That's what Daniel Shipman does. But it would be really convenient actually for my graphic novel class too, because I could hold pictures of comics up to that camera and still talk to the other camera. All right, that would make it easier for me to draw things like this. Okay, again, I wish I could type, but I can't. So that's the idea. So what we want to know is, we know that the number is going to be reported along the blue scale here, but we want it to be demonstrated along the green scale here. So what the map function does is it lets you slice a particular point. That's not vertical, that should be vertical. Let me make it here. So there we go, that's good enough. The map function lets you interpolate this scale onto this scale, and it also lets you slice any particular point within that. So whatever, so think of it of giving it the 0.11 on this scale will give you whatever the number is over here, and you don't even need to know the number here. As long as the map function can report it, you can feed it to your rectangle function and then draw the rectangle at that width accordingly. Let's figure that out. Remember, keep in mind the key thing with the map function is it's taking this scale and interpolating it along this scale and giving you one part of it at a time. So let's take a look. So what we're going to do is make a little variable here. We don't have to do this as variables, but we could do it. We're going to do it this way to be as clear as possible. We'll say let our width now. So this is going to be a combined kind of value. It's going to use the map function, and the map function takes 5 arguments. So what it wants to know first of all is what is the input value? Like what is the value on the green or the blue scale here that you want me to interpolate on the green scale? So what is our starting value here from? And we don't need to know it ahead of time. This is going to be changing throughout the day. So this is the value that we've assigned to hour first. So we'll do that here. Let hour. Let hour width equal map, and then that's the value we're going to take as input. Oops, don't want to put my spaces there. So we need to know the scale that this is coming in on. Like what are the potential values for hour? And we established that we already know that goes from 0 to 23. So that's your first set of numbers. These two numbers go together, but they're listed as equals within this comma separated list. And then the final pair of numbers is the new scale that we want to map this onto. When we know that's going to be 0 as the low end, and then on the high end, 600. We know it's 600 because that's our current width, right? That's what we did on this whiteboard here. But we could also just do it as width, lowercase word width, because that's a keyword, an environment variable that P5JS knows about. So now, down when I draw this rectangle, I can just say hour width. I can just drop that in there. I don't need to calculate it. I don't need to try to remember how to do the math. I just hit play, and then it should work. Okay, so that's that you kind of just have to trust me on this one because it's just a rectangle and we kind of know where it is. But let's see if we can do this with a little bit more action and a little bit more, a bit more interesting. So let's do the same thing, and I'll kind of talk through this one again. Let's do the same thing for minutes. So minutes, we'll make a new variable called minute width, and we'll do map mn because we're taking in whatever the current minute is, and then we're going to map it on a new scale. We know that minutes are on a scale from 0 to 59, right? That's how they work their way around the clock. And we want to map that on the same scale we did before, on the scale of 0 to up to a maximum of whatever the width is of the canvas. And so that should be there. Let's fill this with a different color so we can see it. We'll say orange, I guess. And then do the same thing. We'll do another rectangle. We'll start this one 50 pixels down from the yellow one, and we'll say minimum width. Minute width, not minimum width, min width, and then we'll say, so that's going to be how wide this particular thing is. Actually, let's give this a little bit of spacing. So we'll say instead of 100 down, we'll say 110 down, and then we'll say minimum width. Again, I did it again, but minute width, and now 50 pixels tall for this one, and we should see a new one pop up. So there you go. That actually is a good progress bar. That tells me that I should be about halfway through this tutorial, and I think I am. So that's good for me to see that. But again, you kind of just have to trust that this is the right time. We could display the numbers as text on here, by the way. I should probably show you how to do that too. But this is okay. I mean, this tells us more or less that that's what that is. Okay, let's try the next one. And this one will be, I think, a lot more obvious that it's working because we'll see it in action because we can watch each second go by. In fact, you'll probably be able to see a couple minutes go by as I'm talking. So SC, we'll call it SC width because this is following the convention that we've established with the other values. And then we'll do seconds. So SC again, 0, 59. That's the scale that seconds are on. It's as far as past the hour, past the minute. And again, we'll just say 0 and width. The same thing actually for all three of these for the scale there. And okay, yeah, I forgot I need to draw it. So let's actually draw it. We'll do. I don't want to do red on black. That's too intense. Let's do white. Okay, and then rectangle again. So 0, and we want to come down 50 from 160. 50 from 110, which would be 160. But let's say 170 just to give it that same spacing. 170, and this is the beginning point of our, you just saw the orange line just moved along there. So this is going to be the beginning point of our second line. We'll say 0, 170, and then we'll say second width and 50 for its height. Of course, we can make these any height, but let's go ahead and see how this looks. There we go, and you see that marching across the screen now, 1 second at a time, and it seems to work nicely. So great, pretty happy with that. Now this is of course just the basic building blocks, but think about what all you can do with this. In this case, I just drew a rectangle and I changed the width based on where the width was or where we were along the seconds, minutes, and hours. Think of all the other things that you can specify with P5.js. Anything that you can represent numerically, you can map onto the current time. So let's try changing just a really simple one. So fill is a color value, and we can think of color as a scale between as a number. Like we could do different ways of representing it, right? But RGB is pretty intuitive. So let's think of it this way. So let's think of, and again, I'll just go and make a variable. I don't really have to, but we'll say second red, and we'll say mapping this onto in RGB mode. The red is the first number in that R, G, and B. It expects 3 values on a scale from 0 to 255. So let's think of it as taking the second, and we'll start as 0 to 255, or no, 0 to 59, but we'll map that onto the scale of 0 to 255, so that this red value should. Now, do I have to put more parentheses in here? Maybe I do, but let's just try it like this. So we'll say red, we'll give it the SC red, and then we'll leave the green and the blue at 110 each. See what happens there? So if I'm right, then this should, well, I don't know. Let's see what happens. Okay, this should change colors throughout the throughout the progress of the minute as seconds increase. So we should see it change colors according to how much red there is. And actually, this will be a good way to kind of understand what red means here. I mean, it's actually kind of stressful to see red increasing, to see something get redder and redder. Like, sort of like psychologically suggests that time is running out and that I need to take action before it hits something else. So maybe this isn't the greatest choice. Yeah, this is actually a good opportunity to illustrate something. But let's let that get all the way to the end. It's actually going to end up kind of pink, I think, because of the other two values, the green and the blue. So kind of a coral. I sort of like that color actually, but still, again, I think increasing redness can be stressful. So notice something that could be kind of, I don't know if you notice this or not, but this is just one number, 0 to 0, and then 59 is another number, and then I'm asking it to map anywhere between these 2 points. Let's say I decide that there's a particular color range that I think looks good. I could say, instead of going from 0 to 255, I could say let's start at 110 and then go to 255, just like your others. And so this way it should get, we'll start pretty red, and then it'll get all the way to that coral color a little bit faster, or it would appear to get there faster. We could also even reverse these. Let's say we like starting with that color, but we want to go all the way down to that blue-green color again. So we can actually reverse this. And you can see that it's going to, we'll have to watch it for a few seconds here, but it will get to the end here, and then when it restarts, it'll be that reddish color again. Hopefully. Let's see. Yeah, there you go. And then as we watch it go, it should reduce that color back down. So pretty nice, right? I think that's looking pretty good. Now I mentioned you might want to actually just print the text of these the time on the screen here, and that might be a good thing to do here, just to make sure that you can kind of use that as your debugging as opposed to printing in the console, or you might have an idea that involves actually printing time numerically. I mean, I think hopefully you can think of something more interesting than just literally printing the time, but it can be done. So let's see how we do this. Like usual, I go to the reference and try to understand like what are the different options you have with the text function. And you've got lots of things here. What we want is this text method. It's going to give us, I think, enough to work with here. So let's see. Text size is going to set whatever the text size is, okay? And that's going to be I'm pretty sure going to be a constant that is applied later on. I'll go down below the bar part. I don't know if 32 is going to be that big, but we'll see. And this wants, I think, the three things. Yeah, I think the three things that this wants is, what do you want to print, and then where do you want to print it? And I think this is going to be the baseline. So this is going to be the bottom left corner of the text as opposed to the top left, which is what you got when you were writing in, when you were creating the rectangle. The text usually works that way, because if you think of how letters are, a few of them hang below, but most sit on a baseline, and even those that hang below, like J or G, sometimes J, but not always, but lowercase g usually. These are lowercase y. These are letters that hang below that baseline. So the baseline is really the reference for type. And so that's what's going to happen here. We'll need to find the right values, but we can probably figure that out. I think fill is going to be the color, so we'll need to make sure we keep an eye on that. But if it's, I guess it'll change color. Now, let's just make the fill white for these. And then for the letters, and then we'll see. Okay, so let's put this down a bit. Let's say 250. So we'll say text. So let's first of all print the hour. Let's say it's going to be hour. You notice I'm not using the map function here. This is just the actual literal hour. And we'll put that at, or I could actually just build this as a string right here. That would be a bit easier and probably a good example in terms of working with strings. So we did print that earlier, right? We did printed the hour, minute, seconds. By giving it those commas right here, the console knows to print those separately. But if we're using this as a string, we need to construct this string to work the way that we want it to look. So let's do that here really quickly. So we'll do HR, and we'll do a plus sign because we're going to be concatenating. And then that's going to be the quote marks around this colon signify that that's a string, and it's going to be attached after the hour. In fact, let's just leave it like that, and then make sure that it goes to the right place, and then we'll come back and add to that string. So let's say it's 2 what do we say, 250? No, 0. Let's say we'll start from the left and go I don't know, 50 in, and then we'll go 250 down. See how that looks. That's actually a pretty good spot. Maybe a little bit lower, but that's pretty good. I'm actually relatively pleased with that. But let's go down a little bit more, 280. Yeah, that looks good. And so let's add the rest of the time. So whenever we're building a string, plus is how you can concatenate, like how you take a string and then add more string to it. So we're going to add more string with whatever the current minute value is, which we have in this variable min, and then we'll add another semicolon, colon, not semicolon, and then the seconds as well. So that should construct a pretty conventional way of looking at what time it is. So there you go, hours, minutes, seconds. Looks pretty good. I just noticed, by the way, that seconds, I didn't realize this, but seconds actually is going to be printed with without a leading 0 if the number is less than 10. So that's kind of interesting. We could control for that, I think, if we want to. I don't really want to because I'm just printing it here for debugging. But if you think of how a digital clock works, it definitely would. Like if you think of the red digital alarm clocks that everyone has, the numbers below 9 are going to be in the far right, and there'll be a gap, right, or a 0, but usually just a gap, at least on mine. So that's something you might want to think about. And you could just write a little conditional here to say, like, is the length of the minute string less than 2, and if so, print it with a 0 first. I mean, that could be done. I'm not going to worry about it at this moment, but if that's something that you're trying to do and you're not sure how, then let me know and I could walk you through that. Excuse me. Okay, so let's try to add, let's see, what are we gonna do next? Oh yeah, let's try some other values besides color. Clocks usually have hands that rotate, and in the P5JS tutorial that Daniel Schiffman does, he uses the arc method to make circles that continue around, and that's pretty cool. I want to try something a little bit, I don't know if easier is the right word, but a little bit different. I want to try to deal with rotation. I want to use rotation as the thing to indicate kind of what time it is. And so I'm going to do this in kind of a strange way. Maybe it's not strange, but this is a way that I'm going to do this. And dealing with rotation does get pretty abstract, and it's sort of hard to explain, like a lot of things. If I had a whiteboard, that would make it a little bit easier. But with this limited whiteboard here, there's no way I could draw this in any reasonable representation. Because we're going to have to deal with rotating the coordinate plane and the drawing plane of this system. At least that's what's going to happen. We don't have to actually deal with it. We can just ask P5JS to do this. But that part is where rotation gets a little weird, I think. So we need something to rotate. I happen to have on my computer a file that is Andrei Markov. I've been kind of using him as an example for a couple of things in this creative coding class, so I will use this picture of Andrei Markov. And images are actually several different ways to deal with images in P5JS, but in this case, this is just a regular static image, so we don't need to get fancy like I was trying to do with animated GIFs the other day. Image load is going to work fine, and all we got to do is create it. And and this I'm going to do outside of the setup or draw function. So notice that this is going to be a global kind of variable. I'm going to call this one AM, just because it's Andrei Markov. And what else do we need to do here? Oh yeah, so we need to make a preload function, so that's good. So that will load it ahead of time and won't need to keep reloading it over and over and over again. So what I found from, and this was not obvious to me at all, but in fact, the path to this is all in the same directory, so it's just am_square.jpg. So that's going to be that, although I'm going to say am for my Andrei Markov variable. And I'll just hit, nothing's going to happen yet because I haven't drawn it, but I'll hit play to make sure there aren't any syntax errors, which is a good idea. Okay, and then the actual loading of it happens here. Oh no, did I just do that? Oh yeah, no, I did that. The actual drawing of it happens here. So this is the image function, image, and then image 00. Now this example has it being done in the setup function, and that makes sense if you're just going to do it there. But what I'm going to be doing here is actually rotating this image. So I need to put it in the draw function where I'm going to be drawing it differently depending on what angle I want it to draw at. So let's draw it here. Let image equal image is the function name, and then the first parameter that the image function expects is the name of the image you want to draw, which I've called am, and then it needs to know where to draw this. It's asking for the top left corner at this point until I tell it otherwise, which I will, but at this point it's asking for the top left corner, and then we're going to put it there, and it should be, yeah, there you go. Now that's pretty big. That's scaling, you know, it's taking up most of my screen here, so I'm going to go ahead and scale this down. I'm going to say that if you want to scale an image as you print it, you can provide an extra set of values to the image function. You can do width divided by 2 and then height divided by 2, and then that will basically make sure that this is half of the width and half of the height as far as its scale. So it should scale it down because it's bigger than that right now. And that's still pretty big. I'm just using width and height as a reference here, by the way. You could just do any number. Like you could just say, give it 200 by 200. But I'm just using these height and width just to keep things, I like to keep things relative if possible so that I can scale things up later on or down. And that looks pretty good. That's a good scale for this. Now what I want to do is try to draw him in the middle of my sketch and then rotate based on any of these parameters, but we'll try them all. But we'll, what hour, minute, second, whatever it is, we want to rotate it according to that. So think of Andrei Markov's head like the hands of a clock, and so it's pointing. He's going to point towards, like, his goatee and his beard and his head are going to be pointing towards whatever time it is on whichever of those three scales we want to put it on. So we need to try to draw him near the middle. So we could calculate that, like we could say width divided by 2, height divided by 2. Now this is actually the wrong way, but I'm going to go ahead and show you how you might get here if you were trying this. So we could put him in there, and now that's, we're closer, but you notice again that's going to be drawing with reference to the top left corner of the JPEG. So this image function says put the top left corner of the image that you're drawing here and here on the x and y coordinate plane. So that's not great, but we could actually, we could do something like, we could do some math, like we could say width divided by 2 minus half of the width divided by 3, because that's how wide the image is. But that's going to get ugly, and it could be, the more code you write, the more opportunity you have to make something wrong. So that would not be the best approach. Conveniently, P5.js has this function called image mode, which lets you reset how it defines the origin of that image. So the origin is the part of it that it draws from. And so if we say, actually, we want image mode center, then it's going to take these two values, width and height divided by 2, as the center of the image. So somewhere around on his face is going to be the actual center, the actual point that it calculates to draw from. So watch what happens if we do that. So there he goes, right? So that's something that looks like we're almost there. And yet there is still a problem that we can't quite get to yet. Maybe I can. Maybe I can kind of work my way towards the problem. And this is going to be a little weird, but let's see if we can do this. So in angle modes, you can do, so whenever you think about an angle in P5.js, there are two different angle modes that it understands, radians and degrees. I find degrees more intuitive because you can think of it like starting here and then rotating 90 degrees, then 180, then 270, then 360 to come all the way back around. And so I'm going to set the angle mode to degrees, and you do that with this angle mode function, and then you use all caps degrees as a constant to say this is the value, this is the mode I want you to set to, just like I did for the image mode. I gave it this all caps center, and that's a constant, and that's now what P5.js is going to draw as. So I want to keep these here. In fact, these are always going to be true, so I'm going to go ahead and put these in the setup function because I don't need to remind P5.js of these two things over and over again. I just want that to always be true. Okay, so let's see, no significant changes yet. But what I'm going to be doing is trying to rotate him. So there is a rotate function, and like most things, again, you go to the documentation, take a look. You can actually rotate X, rotate Y, rotate Z if you're in 3D mode, which we're not at this moment. But you've got here a couple of interesting things here that we haven't quite seen before. So we've got this translate function, which you'll see why that's important in a moment. But then you've got the rectangle bit here to draw this rectangle, and that's how we draw rectangles. This rectangle has a negative value though, which could be kind of interesting. And well, I can explain why, but I think in our image example, it's better just to focus on the translate option here. But let's try rotate first and then see why that doesn't quite get us what we want. Okay, so remember we're in angle mode. So let's say we wanted to, eventually I'm going to map this to different parts of the time, but just to kind of keep things simple for debugging, let's try rotating this 90 degrees. So this is sometimes a good practice whenever you're coding is to kind of think about or even say out loud what you expect is about to happen once you introduce a change, and then see if that did happen. And then if it doesn't happen, go back and try to think about your assumptions. Like think about why you thought that would happen, and then think about which of those assumptions might be incorrect. So at this point, I'm going to say something that I know is incorrect, but that you might be thinking, or that I initially was thinking in this case. I expect that Andrei Markov's face, being currently oriented vertically, by rotating 90 degrees is going to go like that on its side. It's actually not going to happen, but what does happen may be confusing. So let's see. Let's watch it. Let's watch it happen. Where did he go? He's gone. Right. So like make the whole image. Yeah. You might think, did I mess up something? Is something happening here that prevents him from being drawn? Like, is there something about this code that made it stop drawing entirely? That's weird. Let's try some different numbers and see if we get different results. Let's try 45 maybe. Oh, now there he is. What's he doing over there? He's kind of peeking out from the side. I kind of like that. But at least that it confirms that it's still drawing the image. It's just when we had it at 90, it was drawing it somewhere that we couldn't see. That's a problem we can hopefully solve, but we definitely need to solve because it's not what we expected. Let's try changing this number and seeing if we can figure out what's happening here. Let's try 15. Okay, interesting. You notice how if you think of it as a big circle, this is actually drawing drawing it with respect to not the center of the image, but with respect to the origin for the canvas, which is way up here in the top left corner of the canvas. So when we say rotate, think about what we're rotating. This word rotate just hangs by itself here, and just like fill is the global fill color for everything that comes after it, so is rotate. Rotate actually rotates the entire coordinate system of the drawing for everything that is drawn after it's set, like after you say rotate. So when you're trying to rotate multiple things, you have to actually set it and then reset it over and over again as you draw. I'm not going to have time to build up that example right now, but that's the kind of thing you have to do when you think about it. And this took me a while to get with P5.js, so I don't know if I'm explaining it well even, but I can show you how to fix it at least. But we're thinking about, so you can see it it almost looks like the hands of a clock, it's ticking its way around the clock, but it's the wrong clock. It's a circle that's bigger than what we can see, and we can only see the bottom right corner of it basically because of where it is. So what we have to do is another function that's going to shift the drawing plane over again before it does this. So we're going to say translate, and translate is going to be that thing that shifts the drawing plane. That's what happens. That's what's happening in this example. Translate width divided by 2, height divided by 2 says put our drawing plane coordinate reference thing in the center of what we see as the canvas. So it says shift it over here to, in this example, it's like right about here. But in our case, it's going to be right around here. So let's try this. So width divided by 2. I got to spell it right. There you go. So it's got to be pink. Width divided by 2, height divided by 2, and that should put that over in the center. And now when we rotate it, this should hopefully look a little different. Now what's he doing down there? Someone's having a hard time. He looks like he's sneaking up on us again down here at the bottom. Now the reason he is, though, is something we can figure out. So remember when I said where to draw him? I said draw him in the middle, width divided by 2, height divided by 2. Well, the middle is now the top left corner in terms of the drawing plane. So it's still drawing in reference to this point, moving right by width divided by 2, and then moving down by height divided by 2. We don't want it to do that anymore. We want to draw this actually in the center. So now that we've translated, we can set his center to be the same as the center of the canvas by drawing him at 0, 0. And now 0, 0 is going to be right there in the middle, and you can see he's already rotated a little bit there with rotating rotating 5 degrees like I had done for my testing. Now if I try rotating 90, I expect this will actually produce the result that I initially expected, which is that he'll be flopped over on his side. And there he goes. So there's a lot of things going on here that are kind of, you kind of have to know, or at least I had to learn from experience. And so that's what I'm trying to tell you here. But these two things really have to work together along with image mode center to get this effect of having something in the middle that rotates, which is a pretty common thing to want to do when you make a clock. You want to have something in the center, you want to rotate it like hands, or you want to have like actual hands moving, or you want to do something else. But this is, I think, a pretty good way to do it. It's just you have to know all of these things together to do it. Okay, so this rotating 90 is, of course, totally arbitrary, but let's try actually giving it a value. We'll do a couple of these, but and then I'll wrap it up here because we've been going for about an hour. So we'll do, let's do the hour first. Let's do hour angle, HR angle, and then remember our good old map function. We can give it a couple of different things. So we can start with the hour, which we know is going to be, it's still 11. It's going to be 12 in a few minutes. We know that that's on a scale of 0 to 23. And now that we are working in degree mode for our angles, we know that that's a scale of 0 to 360, right? So that's, or is it 359? It might be 359. Let's do 359. I feel like that's safer. So, okay. So now instead of rotating 90 degrees, we can just set him to rotate on our angle. And that should put him, yeah, about upside down, right? Because it's almost halfway through the 23 hours of the day, 24 hours a day, but they start counting at 0. So that's going to be, it's pretty good. You notice, by the way, like we could put him somewhere else. I put him width divided by 2, height divided by 2, because that was, I think, a bit more intuitive. But with this translate thing, we could actually move him somewhere else. In fact, why don't we do, let's actually put him down a bit, right? Because so, and this is, it should be all we have to change, right? So height divided by 2 would put him here. I guess height times 0.7 or so would put him a little bit farther down. Let's see. Yeah, that's pretty good. So that's, you know, and you notice he's still going to draw at the right, he's still going to rotate around that same center, hopefully. We'll see it a bit more clearly if we try some more angle values. So let's do angle equals map minutes, and we know minutes are 0 to 59 or 0 to 359. And let's try rotating him according to whatever our minutes are. And we can see actually it's minute 53 right now on my clock. And so let's see, that should put him almost all the way back around. That looks about right. It looks a little bit not quite as far over as I thought, but you know, I kind of expected him to be more, but I guess that's okay. You know, we'll trust the map. Let's try it on seconds, and this should be a little bit easier to kind of sanity check. So we'll do map the second value, which we know is coming in. We'll do 0 to 59, and then we'll do 0 to, oh, you know what? No, I did right. Okay, sorry, I was thinking 0 to 359. I don't know if you can hear my daughter's crying in the background. That sounds like an angry crying. She's been throwing temper tantrums about having access to entertainment, and when she doesn't get what she wants, she screams. So here we go. So we can watch the seconds here, and we should see these two things, the progress bar going and now the rotating going, should reset or get to, you know, vertical and all the way over at the same time. It looks like they do here. So yeah, I mean, there was the difference was a little off, I felt like. Maybe this should be 0 to 360. Or maybe just there's not an even way to divide it, you know? Let's see, let's try this. Let's see if that looks a little bit better, although I don't think it's gonna look that much different. But it just seemed like that last tick was a little bit less than the other ticks in terms of moving. And this would be easier to see if this was like a single line or other kinds of things. But let's just see how this looks when it comes around. And then I'll wrap it up and see if I can help my daughter adjust her attitude or whatever she needs. I hope my audio is not too loud, by the way. I'm seeing it clipping a little bit still, even though I adjusted it down. Let me pull it down a bit. It's hard to test because I talk louder than like when I'm testing, it's hard to talk as loud as I do when I'm teaching. Here comes it there. Okay, actually, so that was interesting. So it looked like it hung for a second. Like it looks like it essentially paused, like it was 360 and then 0 at the same time. I mean, it was 360 and then it was 0 after being 360, and that was for 2 ticks, and so that's why it looked like it paused. So yeah, I mean, we could maybe tweak this, but I think this is close enough, right? In terms of the ticking. I think it's 359, but it's really going to be 360 minus whatever the current divisor is for the mapping function. So I don't know. I don't really feel like calculating that out. Okay, so it's kind of a clock. It's something. It's not super interesting, but we've got here 3 different ways of thinking about what time it is and representing the time. We could imagine, maybe I'll do this tomorrow just to have another example, nesting 3 images. And so one is hours, one is minutes, one is seconds, and then have them kind of inside each other, and then that can give us a way to represent time on a more, like with all those 3 different constants visible at the same time. That could be interesting and also a bit more useful. I should say for this assignment, usefulness is not important. So if your clock is not readable, I'm not worried about it. Let me show you an example, actually. Bianca was a student last year, and she did some really interesting clocks. Sorry, but I don't know. You probably can't hear the screaming in the background, but I can. Okay, so this is, and I'm sure she's fine. She's just unhappy. All right, so these are some clocks by Bianca that I thought turned out really nicely, and I wish she did better than them, but this is one where it's based on abstract art, and I forget the artist is Kazimir Malevich, and I'm not familiar with that artist actually, but each of these shapes here is changing in some way with respect to time. So she's found a way to map the time functions onto different properties of this painting image, and it shows, you can see this triangle kind of pulsating as it moves. I think it's really a brilliant use of abstract art to create a representation of time. So this one at the top middle is, she describes them by their location. This is one which is based on several different artists together, I think. I think Van Doesburg would be really interesting. He did a lot with like essentially pixel art kind of work, but in the 1920s and before pixels were a thing. So pretty interesting to think about maybe using his style. But this is something where if you'll notice as the minute changes, like obviously the circle's getting bigger with the seconds, but then watch the triangles and the other shapes as they, well, whenever it gets to the rollover, which should be happening in a few seconds. There it goes. Yeah. Wait, did they change? I forgot to look. I was thinking about something else. Yeah, so that's another abstract use of time, or abstract representation of time. But the other one, yeah, so the final one, this one's a little bit harder. I guess this is Piet Mondrian, and Mondrian does these images with the rectangles, and I recall Bianca had a hard time figuring this one out in terms of like what to turn on and off in different ways to represent time. And I think you might think of like changing the shapes of the rectangles, but that's going to get really tricky because these rectangles depend on each other in ways that are kind of hard to map. And I think that was a challenge she ran into. But as it is, it's a nice representation of Piet Mondrian style. All right, so this is just one approach. This was Bianca's. I liked it a lot. I liked a lot of other ones as well, but this is another good place where you might find inspiration. This is linked in the assignment description. This is John Maida's. Well, it's Golden Levin's links to things, including John Maida's examples of time. So check it out. All right, well, whoever's watching, thanks for watching. If you're watching this on the stream, if you're watching this in the archive, hopefully it was still helpful. And really, just in terms of the nuts and bolts of P5JS, again, Dan Chipman is the way to go. Hopefully I've explained things well enough here too, maybe a bit slower. And between the two of these, hopefully it's helpful. But yeah. All right, well, I will wrap it up here. Thanks for watching and have a good day.